So in this lecture we'll find out the area of the green shape using two different methods. In the drawing we have a circle. Inside this circle we have triangle ABC. We know that side AB of this triangle equals to 14 units. Side BC of triangle ABC equals to 14 units instead. Side AC equals to 15 units. Our mission is to find out the area of this green shape. Okay. So first of all, I will present to you a new rule and we will implement the new rule in our drawing. The new rule is rule number 4. According to rule number 4, the area of triangle ABC is equals to the square root of S times A, the square root of S times S times the square root of S times S minus A times S minus B times S minus C. So we have here triangle ABC. We know that side AB of this triangle equals to units, side BC equals to units, and side AC equals to units in itself. So A, B, and C are the side lengths of this triangle, triangle ABC, and S is the semi-perimeter of this triangle. The semi-perimeter of any triangle is the perimeter over 2. The perimeter is A plus B plus C, that is the sum of its side lengths, and we'll divide the perimeter by 2, we'll get the semi-perimeter S. So S equals to A plus B plus C over 2. A is the length of side AB, B is the length of side BC, and C is the length of side AC. So the area of triangle ABC according to the new formula equals to the square root of S times S minus A times S minus B times S minus C. So we can actually implement rule number 4 in our drawing. First of all, we define the length of side AB as A, and we know that A equals to 13 units, so side AB equals to 13 units in its length. We will define the length of side BC as B, and we know that B equals to 14, or BC equals to 14. We define the length of side AC of this triangle, triangle ABC as C, and we know that AC is equals to C. According to our definition, it is equals to 15 units. So I write it down. According to our definition, A equals to 13, B equals to 14, B equals to 14, and C equals to 15. Now we calculate the semi-perimeter of this triangle, triangle ABC. We know that the semi-perimeter of any triangle equals to the perimeter that is A plus B plus C over 2. A is 13, plus B is 14, plus C is 15 over 2. 13 plus 14 is 27, plus 15 over 2. 27 plus 15 is 42, and 42 over 2 is 21. So finally we found out that the semi-perimeter S of our triangle, triangle ABC equals to 21 units. A equals to 13, B equals to 14, and C equals to 15. So according to rule number 4, the area of our triangle ABC will be equal to the square root of S times S minus A times S minus B times S minus C. So it is equals to S is 21, so S minus A is 13 and S is 21, so S minus A in total it is equals to 21 minus 13 times S minus B. S is 21, B is 14, so S minus B in total is 21 minus 14 times S minus C. Again, S is 21, C is 15, so S minus C in total is 21 minus 15. So the area of triangle ABC equals to 21, and 21 minus 14 is 8, times 21 minus 14 is 7, times 21 minus 15 is 6. So in total, the area of triangle ABC, according to rule number 4, equals to the square root of 21 times 8 times 7 times 6. That is to say, it is equals to the square root of, we substitute 21 by 3 times 7 times 8. We substitute 8 by 2 times 2 times 2. We have to multiply it by 7 times 6. We substitute 6 by 3 times 2. Okay. So actually found out that the area of triangle ABC, you can arrange differently the numbers here, and we get that according to rule number 4, the area of our triangle ABC is equals to the square root of 3 times 3 times 7 times 7 times 2 times 2. We have 2 4 times, so it is again times 2 times 2. So actually found out that the area of triangle ABC equals to the square root of 3 times 3 is 3, times the square root of 7 times 7 is 7, times the square root of 2 times 2 is 2, and finally we have again the square root of 2 times 2 is 2. So the area of triangle ABC equals to 3 times 7 is 21 times 2 times 2. 21 times 2 is 42, and 42 times 2 is 84. So if I found out that the area of triangle ABC in total, it is equals to 84 square units. Repeat again. The area of this triangle, triangle ABC, equals to 84 square units according to the new formula, rule number 4. In the next step, I will present to you a new rule and we will implement the new rule in our drawing. This is actually rule number 6. According to rule number 6, the radius of a circle that blocks triangle ABC is equals to R equals to A times B times C over 4 times the area of triangle ABC. So in the drawing we have a circle. This circle blocks triangle ABC. We know that the length of side AB of triangle ABC equals 2 units. Side BC equals to B units in its length, and side AC equals to C units in its length. According to our definition, the radius of this circle that blocks triangle ABC equals to capital R. So according to the new rule number 6, the value of capital R, that is the radius of this circle that blocks triangle ABC, equals to A times B times C, that is the multiplication of the side lengths of this triangle ABC by each other over 4 times the area of this triangle ABC. So we can actually implement rule number 6 in our drawing. I will remind you that we have already found out that the area of triangle ABC equals to 84 square units. So actually, according to rule number 6, so first of all, we define the radius of this circle as R. Or capital R. So according to rule number 6, the radius of our circle must be equal to A times B times C, that is the multiplication of the side lengths of triangle ABC by each other over 4 times the area of triangle ABC. So the radius capital R of this circle equals to A, that is 13, times B, that is 14, times C, that is 15, over 4 times the area of triangle ABC. We already found out that the area of triangle ABC equals to 84 square units. Here we divide both the numerator and the denominator of this expression by 14. So in the numerator we have 14, 14 over 14 is 1, so we left, in the numerator we left only with 13 times 15 after we divide it by 14. So we will divide also the denominator by 14. In the denominator we have 4 times 84 over 14 is 6. So in total, in the denominator we have 4 times 6. Here we divide both the numerator and the denominator of this expression by 3, and we get that in the numerator we have 13 times 15 over 3 is 5. So after we divide the numerator by 3, we left only with 13 times 5. In the denominator we have 4 times 6 over 3 is 2. So in total, in the denominator, after we divide it by 3, we left only with 4 times 2. 4 times 2 is 8, and 13 times 5 is 65. So I actually found out that the radius of this circle capital R equals to 65 over 8 units. And what is the area of the green shape? From the drawing, it is very easy to see that the area of the green shape is equal to the area of the circle minus the area of triangle ABC. Repeat again. The area of the green shape in total, it is equal to the area of the circle minus the area of triangle ABC. The area of the circle is pi r squared minus the area of triangle ABC. We already found out that the area of triangle ABC equals to 84 square units. So the area of triangle ABC is 84 square units. Pi r squared, r is 65 over 8, therefore r squared is 65 over 8 squared. So the area of the circle in total is equal to pi times r squared. R is 65 over 8, therefore r squared is 65 over 8 squared, minus the area of triangle ABC, that is 84 square units. So actually, this expression in total, it is equal to 207.394 square units. 207.394 square units minus 84. So actually, 207.394 minus 84 is 123.394 square units. So actually found out that the area of the green shape in total it is equal to 123.394 square units. And that is the answer to our question. Repeat again. The area of this green shape equals to 123.394 square units. So we finished with the first method. In the next step, I will present to you how to find out the area of this green shape according to the second method. In the second method, we will do a construction, that is to say from point A, we will draw perpendicular on BC. So, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as M. We define the length of side AM as H. We define the length of side BM as X. It is given us the question that side BC of this triangle ABC equals to 14 units. According to our definition, BM equals to X. Therefore, the missing side CM, equals to CB minus MB. So CM equals to CB, that is 14, minus MB, that is X. So in total, CM equals to 14 minus X. In the next step, I will copy the right triangle, triangle ABM in the new page, and we will implement on this triangle A and B, the Pythagoras theorem. So actually, this is the right triangle A and B that I copied from the original drawing. The hypotenuse AB equals to 13 units in its length according to what is given as the question. AM equals to H and BM equals to X according to our definition. Here by PT is abbreviation for Pythagoras theorem. In this right triangle A and B, according to the Pythagoras theorem, we get that AB squared equals to AM squared plus BM squared. AB is 13, therefore AB squared is 13 squared, that is 169, and it is equals to AM squared. AM is H, therefore AM squared is H squared, plus BM squared. BM is X, therefore BM squared is X squared. We found out that according to equation number 1, 169 equals to H squared plus X squared. Here we subtract X squared from this equation number 1, and we get that according to equation number 1, H squared equals to 169 minus X squared. In the next step, I will copy the right triangle AMC in the new page, and we'll implement the Pythagoras theorem on this right triangle AMC. So actually, this is the right triangle AMC that I copied from the original drawing. AC equals to 15 units according to what is given as the question. AM equals to H and MC equals to 14 minus X. So in this right triangle AMC, according to the Pythagoras theorem by PT's abbreviation for Pythagoras theorem, according to the Pythagoras theorem, in this triangle AMC, AC squared equals to AM squared plus MC squared. AC is 15, therefore AC squared is 15 squared, that is 225. And it is equals to AM squared. AM is H, therefore AM squared is H squared plus MC squared. MC is 14 minus X, therefore MC squared is 14 minus X squared. Here we'll subtract 14 minus x squared from this equation number 2. And we get that according to this equation number 2, x squared equals to 225 minus 14 minus x squared. Repeat again, that according to equation number 2, we actually found out that x squared equals to 225 minus 14 minus x squared. And according to equation number 1, we already found out that x squared equals to 169 minus x squared. So we have two different expressions for x squared. Therefore, we create equation number 3 that states that x squared according to equation number 1 must be equal to x squared according to equation number 2. X squared according to equation number 1 equals to 169 minus x squared, and it must be equal to x squared according to equation number 2. X squared according to equation number 2 equals to 225 minus 14 minus x squared. So actually found out that according to equation number 3, (169 minus x squared equals to 225 minus 14 minus x squared equals to 14 squared, that is 196, plus x squared minus 2 times 14x, that is minus 28x. So actually found out that according to this equation number 3, 169 minus x squared equals to 225. We will open the brackets here. Will be minus 196 minus x squared, minus and minus is plus, so it is plus 28x. So here we have minus x squared on both sides of the equation, so minus x squared will get cancelled. So in this side of the equation, after we cancelled minus x squared, we left only with 169. That is equals to 225 minus 196 is 29 plus 28x. So here we subtract 29 from this equation number 3, and we get that according to equation number 3, 169 minus 29 is 140. It is equals to 28x. Here we divide this equation number 3 by 28, and finally we get that x equals to 140 over 28 is 5. So x equals to 5 units. And according to equation number 1, we know that x squared equals to 169 minus x squared. So x squared equals to 169 minus x squared, but x is 5, therefore x squared is 25. So it is minus x squared is minus 25. So actually we found out that x squared equals to 169 minus 25 is 144. So according to equation number 1, x squared equals to 144. Here we'll take a root out of this equation, and we'll get that h equals to the square root of 124, that is 12. So if I find out that x equals to 5 and h equals to 12 units, so I can write here that h equals to 12 units in its length. In the next step, we define the center of this circle as O, and we join points O and A together by a straight line. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of this circle. We define the radius of this circle as R, so OA equals to R. We will extend the radius AO by a straight line until it touches the circle. And we define the touching point of the extended radius AO in this circle as point P. So here we have point O is the center of the circle, point P is the point of the circle itself, so for OP is the radius of this circle that is equals to R, according to our definition. By doing this construction, we created here chord AP, and this chord AP passes through point O, that is the center of the circle. And we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, chord AP is the diameter of the circle. And we know that the diameter of any circle is twice as long as the radius. The radius of this circle is R, therefore the diameter AP equals to 2R. You can see it from the drawing itself, that AP in total equals to R plus R, that is 2R. In the next step, we join points C and P together by a straight line. By joining points P and C, we created here peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. And we have here rule number 7 that says that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. I'll repeat again on rule number 7. According to rule number 7, if a peripheral angle rests on the diameter of the circle, then it is equal to 90 degrees. In the drawing, we have peripheral angle ACB that rests on AB, that is the diameter of the circle. Therefore, this peripheral angle ACB equals to 90 degrees. We can implement rule number 7 in our drawing. Why? Because in our drawing, we have this peripheral angle ACP that rests on AP, that is the diameter of the circle. Therefore, according to rule number 7, peripheral angle ACP equals to 90 degrees. In the next step, we implement rule number 8 in our drawing. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. So, in the drawing, we have peripheral angle ADB that rests on chord AB, and we also have another peripheral angle ACB, that rests on the same chord AB. And because of the fact that those two peripheral angles, they both rest on the same chord AB, they must be equal to each other. That is to say, peripheral angle ADB equals to this peripheral angle ACB. So if peripheral angle ADB equals to theta, then peripheral angle ACB must be also equal to theta. We can actually implement rule number 8 in our drawing. Why? Because in our drawing we have peripheral angle APC that rests on chord AC, and we also have another peripheral angle ABC that rests on the same chord AC. So actually those two peripheral angles, they both rest on the same chord AC, therefore they must be equal to each other. So if we define peripheral angle APC as theta, then the other peripheral angle ABC that rests on the same chord AC, must be also equal to theta according to rule number 8. So we'll focus on the right triangle ABM. On this right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle A must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, we'll focus on the right triangle APC. On this right triangle APC, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. In the next step, we'll prove that the right triangle AMB, this right triangle AMB, is similar to the right triangle APC. We prove that those two right triangles are similar to each other. So I write it down. We prove that the right triangle AMB, is similar to the right triangle APC. So, why those two right triangles are similar to each other? First of all, those two angles, they are both equal to theta, therefore they are equal to each other. So we can write down that this angle is angle ABM, in triangle AMB, and it is equal to this angle, that is actually angle APC, in triangle ACP. Repeat again. Angle ABM in triangle AMB is equal to angle APC in triangle ACP. They are both equal to theta, therefore they are equal to each other. In addition, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So we can write down that this angle is angle AMB in triangle ABM. And it is equal to this angle, that is actually angle ACP in triangle APC. I'll repeat again. Angle AMB in triangle ABM equals to angle ACP in triangle APC. They are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle MAB in triangle ABM. And it is equal to this angle, that's actually angle PAC in triangle APC. repeat again. Angle MAB in triangle ABM equals to angle PAC in triangle ACP. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in this triangle ABM are correspondingly equal to all the three angles in this triangle APC. Therefore we actually proved that those two right triangles are similar to each other according to angle similarity rule. So I'll write it down. We actually proved that this right triangle A and B is similar, this is the sign of similar, to the right triangle APC, according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derived that the following relationship exists between their sides. We derived that AB in triangle AMB over AP in triangle APC is equals to AM in triangle AMB over AC in triangle APC. Repeat again, we derived that AB over AP equals to AM over AC. AB is 13 over AP is the diameter of the circle, that is 2R, and it is equals to AM. AM is 12 over AC is 15. So I can find out that 13 over 2R equals to 12 over 15. Here we'll cross multiply this equation, and we'll get that 13 times 15 equals to 12 times 2R. Here we'll divide this equation by 12, and finally we get that 2R equals to 13 times 15 over 12. Here we'll divide this equation by 2, and finally we get that R, the radius of the circle R, equals to 13 times 15 over 2 times 12. So here we divide this, both the numerator and the denominator of this expression by 3. So in the numerator we have 13 times 15 over 3 is 5. So in total, in the numerator, after we divided by 3, we left only with 13 times 5 over 2 times 12 over 3 is 4. So in total, after we divide the numerator by 3, we left only with 2 times 4 in the denominator. 13 times 5 is 65, and 2 times 4 is 8. So in conclusion, we found out that the radius of this circle R equals to 65 over 8 units. Our mission is to find out the area of this green shape. The area of this green shape, it is very easy to see that the area of this green shape equals to the area of the circle minus the area of triangle ABC. So we write it down. The area of the green shape in total it is equals to the area of the circle minus the area of triangle ABC. The area of the circle is pi r squared minus the area of triangle ABC. We have already found out that what is the area of triangle ABC? The area of this triangle ABC, equals to the base of the triangle, that is BC, times the height to the base, that is H, over 2. Repeat again. The area of triangle ABC equals to the base, that is BC, times the height to the base, that is H, over 2. So the area of the green shape is equals to pi r squared, that is the area of the circle. R is 65 over 8, therefore r squared is 65 over 8 squared. So the area of the circle in total equals to pi times 65 over 8 squared minus the area of triangle ABC. The area of triangle ABC equals to BC, that is 14, times H, that is 12, over 2. This expression, pi times 65 over 8 squared, in total it is equals to 207.394 square units, minus the area of triangle ABC. The area of triangle ABC equals to 14 over 2, that is 7. 7 times 12 is 84. So in total, the area of triangle ABC equals to 84 square units. 207.394 minus 84 equals to 123.394 square units. So the area of the green shape in total, according to the second method also, it is equals to 123.394 square units. Repeat again, the area of this green shape according to the second method also, it is also equals to 123.394 square units. We finish with the second method. In the next step I will summarize the lecture. We'll start with the first method. In this lecture we found out the area of this green shape. So in the drawing we have a circle. Inside this circle we have triangle ABC. We know that side AB of this triangle ABC equals to 13 units, side BC equals to 14 units in its length, and side AC equals to 15 units in its length. Our mission is to find out the area of this green shape. So first of all I presented to you rule number 4, and we implemented rule number 4 in our drawing. According to rule number 4, the area of triangle ABC equals to the square root of S times S minus A times S minus B times S minus C. Here we have triangle ABC that could be any triangle. The length of side AB is A, side BC equals to B units in its length, and side AC equals to C units in its length. And the S is the semi-perimeter of the triangle, that is equals to the perimeter, that is A plus B plus C, that is the sum of its side lengths, over 2. So S is A plus B plus C over 2. A is the length of side AB, B is the length of side BC, and C is the length of side AC. And repeat again that according to the new rule number 4, the area of triangle ABC equals to the square root of S times S minus A times S minus B times S minus C. So we can actually implement rule number 4 in our drawing. First of all, we defined the length of side AB as A, and A equals to 13. We define the length of side BC of this triangle ABC as B, and B equals to 14 according to what is given as the equation. And we define the length of side AC of this triangle ABC as C, and C equals to 15 units according to what is given as the equation. Repeat again. A equals to 13, B equals to 14, and C equals to 15. According to our definition. In the next step, we found out the semi-perimeter of this triangle ABC. According to the new rule number 4, the semi-perimeter equals to A plus B plus C over 2. A is 13, B is 14, and C is 15. If we divide it by 2, we get the semi-perimeter S. 13 plus 14 is 27, plus 15 over 2. 27 plus 15 is 42. 42 over 2 is 21. So finally we found out that the semi-perimeter of this triangle ABC equals to 21 units. S equals to 21, A equals to 13, B equals to 14, and C equals to 15. And the area of this triangle ABC, according to the new rule number 4, equals to the square root of S times S minus A times S minus B times S minus C. So the area equals to the square root of S is 21. S minus A is 21 minus 13. S minus B is 21 minus 14, and S minus C is 21 minus 15. So the area of the triangle ABC equals to 21 times 21 minus 14 is 8, times 21 minus 14 is 7, times 21 minus 15 is 6. So the area of triangle ABC equals to the square root of 21 times 8 times 7 times 6. Here we substitute 21 by 3 times 7. We substitute 8 by 2 times 2 times 2. We have here 7. I copy it here. And we substitute 6 by 3 times 2. Then we arrange the numbers here. We found out actually that the area of triangle ABC equals to the square root of 3 times 3 times 7 times 7 times 2 times 2 times 2 times 2. The square root of 3 times 3 is 3. The square root of 7 times 7 is 7. The square root of 2 times 2 is 2. And the square root of 2 times 2 again is 2. So the area of triangle ABC in total is equals to 3 times 7, that is 21, times 2 times 2. 21 times 2 is 42, and 42 times 2 is 84. So in conclusion, we found out that the area of this triangle ABC according to the new formula rule number 4, it is equals to 84 square units. The area of triangle ABC is 84 square units. Then I presented to you rule number 6 and implemented rule number 6 in our drawing. According to rule number 6, the radius of a circle that blocks triangle ABC is equals to R equals to A times B times C over 4 times the area of triangle ABC. So in the drawing we have this circle. This circle blocks this triangle ABC. According to our definition, the radius of this circle is R. So according to rule number 6, the value of R is A times B times C. AB is the length of side A, BC is the length of side B, and AC is the length of side C. So the radius of this circle R equals to A times B times C, that is the multiplication of the sides lengths of the triangle by each other, over 4 times the area of this triangle ABC, that is blocked by this circle. So we can actually implement rule number 4 in our drawing. Why? Because in our drawing we have this circle that blocks triangle ABC. Therefore, the radius of this circle R that blocks triangle ABC, according to rule number 6, it is equal to A times B times C over 4 times the area of triangle ABC. Okay. We have already found out that the area of triangle ABC equals to 84 square units. So the radius R of this circle that blocks this triangle ABC equals to A times B times C. A is 13, B is 14, and C is 15. Over 4 times the area of triangle ABC. The area of triangle ABC is 84. Here we divided both the numerator and the denominator of this expression by 14. In the numerator we have 14, so 14 over 14 is 1. We left only, after we divided by 14, we left only with 13 times 15 over 4 times 84. 84 over 14 is 6, so in total, in the denominator, we left only with 4 times 6. In the next step, we divided both the numerator and the denominator of this expression by 3. So in the numerator, we have 13 times 15 over 3 is 5. So in total, in the numerator, we have 13 times 5 after we divided by 3. We have to divide also the denominator by 3. In the denominator, we have 4 times 6 over 3 is 2. So in total, after we divide the numerator by 3, we left only with 4 times 2. 4 times 2 is 8, and 13 times 5 is 65. That is to say, the radius of this circle that blocks triangle ABC, the radius R equals to 65 over 8. Repeat again. The radius R of this circle that blocks triangle ABC equals to 65 over 8 units. It is very easy to see that the area of the green shape equals to the area of the circle minus the area of triangle ABC. Repeat again, the area of the green shape in total it is equals to the area of the circle minus the area of triangle ABC. The area of the circle is pi r square, and we already found out that the area of triangle ABC equals to 84 square units. So the area of the circle is pi r square, but r is 65 over 8, therefore r square is 65 over 8 square. So in total the area of the circle pi r square is pi times 65 over 8 square minus the area of triangle ABC. We already found out that the area of triangle ABC equals to 84 square units. This expression in total equals to 207.394 square units minus 84, that is the area of triangle ABC. 207.394 minus 84 equals to 123.394 square units. So we actually found out that the area of this green shape, according to the first method, equals to 123.394 square units. We finished with the first method. In the next step, I actually presented to you how to find out the area of this green shape according to the second method. In the second method, we did the construction, that is to say from point A, we draw perpendicular on BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as M. We define the length of side AM as H. We define the length of side BM as X. What is the length of side CM? From the drawing, it is very easy to see that CM equals to CB minus MB. That is to say, CM equals to CB, that is 14, minus MB, that is X. So in total, CM equals to 14 minus X. Then I copied the right triangle ABM in a new page, and we implemented the Pythagoras theorem in this right triangle ABM. Actually, this is the right triangle ABM or A and B that I copied from the original drawing. AB equals to 13 units in itself according to what is given as the question. AM equals to H and BM equals to X according to our definition. according to the here by PT's equation for Pythagoras theorem, according to the Pythagoras theorem in this right triangle, triangle ABM, AB squared equals to AM squared plus BM squared. AB is 13, therefore AB squared is 13 squared, that is 169, and it is equals to AM squared. AM is 8, therefore AM squared is 8 squared plus MB squared. MB is x, therefore MB squared is x squared. So in conclusion, I found out that according to equation number 1, 169 equals to x squared plus x squared. Here we subtracted x squared from this equation, equation number 1. And finally found out that according to equation number 1, h squared equals to 169 minus x squared. Then I copied the right triangle, triangle AMC in the new page and implemented the Pythagoras theorem in this right triangle, triangle AMC. This is the right triangle, triangle AMC that I copied from the original domain. AC equals to 15 units in itself, according to what is given as the equation. AM equals to h, according to our definition, and MC equals to 14 minus x, according to what we have already found out. In this right triangle, triangle AMC, according to the Pythagoras theorem, we get that AC squared equals to AM squared plus MC squared. AC is 15, therefore AC squared is 15 squared, that is 225, and that is equal to AM squared. AM is x, therefore AM squared is x squared plus MC squared. MC is 14 minus x, therefore MC squared is 14 minus x squared. So in conclusion, found out that according to equation number 2, 225 equals to h squared plus 14 minus x squared. Here we subtracted 14 minus x squared from this equation, and finally we found out that according to equation number 2, h squared equals to 225 minus 14 minus x squared. Repeat again, according to equation number 2, we found out that x squared equals to 225 minus 14 minus x squared. This is according to equation number 2, while according to equation number 1, we have already found out that h squared equals to 169 minus x squared. So we have two different expressions for h squared. Therefore, we created equation number 3 that states that h squared according to equation number 1 must be equal to h squared according to equation number 2. H squared according to equation number 1 equals to 169 minus x squared. And it must be equal to h squared according to equation number 2. H squared according to equation number 2 equals to 225 minus 14 minus x squared. So according to this equation, equation number 3, 169 minus x squared equals to 225 minus 14 minus x squared equals to 14 squared, that is 196, plus x squared, minus 2 times 14x, that is minus 28x. So according to this equation, equation number 3, we found out that 169 minus x squared equals to 225. We open the brackets here. After we open the brackets, we get here minus 196 minus x squared, minus is plus, so it is plus 28x. Here we have minus x squared on both sides of the equation, so minus x squared will get cancelled. After we cancel minus x squared, in this side of the equation we have only 169. On the other side of the equation we have 225 minus 196 is 29 plus 28x. So in total we found out that according to equation number 3, 169 equals to 29 plus 28x. Here we subtracted 29 from this equation, equation number 3, and found out that 169 minus 29 is 140, that is equal to 28x. Here we divided this equation, equation number 3 by 28, and finally found out that x equals to 140 over 28, that is 5. So x equals to 5. Here we have, according to equation number 1, h squared equals to 169 minus x squared. So h squared equals to 169 minus x squared, but x is 5, therefore x squared is 25. So in total, according to equation number 1, we found out that h squared equals to 169 minus 25. 169 minus 25 is 144. So in conclusion, we found out that according to equation number 1, h squared equals to 144. Here we took out of this equation, equation number 1, we found out that h equals to the square root of 144. The square root of 144 is 12, so h equals to 12. So here x equals to 5 and h equals to 12 units in its length. Then we define the center of this circle as O, and we join points O and A together by straight line. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of this circle. We define the radius of this circle as R. Then we extended the radius AO by straight line until it touches the circle. We define the touching point of the extended radius AO in this circle as P. When you extend the straight line by straight line, the result is a straight line. So AP is a straight line. Actually, AP is not only a straight line, but it is also a chord that passes through point O, that is the center of the circle. And you know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, AP is the diameter of the circle. Here, point O is the center of the circle, point P is the point of the circle itself. Therefore, OP is the radius of the circle that is equal to R. So in total, AP equals to R plus R, that is to R. And we also know that the diameter of any circle equals to 2 times the radius. The radius is R, therefore the diameter AP is 2R. Okay? Then we joined points P and C together by a straight line. By joining points P and C, we created peripheral angle ACP. This peripheral angle ACP rests on chord AP, that is the diameter of the circle. And according to rule number 7, any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. Repeat again on rule number 7. According to rule number 7, if a peripheral angle rests on the diameter of the circle, then it is equal to 90 degrees. In the drawing we have peripheral angle ACB that rests on AB, that is the diameter of the circle. Therefore, this peripheral angle ACB equals to 90 degrees. We can actually implement rule number 7 in our drawing. Why? Because in our drawing we have peripheral angle ACP, this peripheral angle ACP that rests on AP, that is the diameter of the circle. Therefore, according to rule number 7, this peripheral angle ACP must be equal to 90 degrees. Okay? Then I presented to you rule number 8 and we implemented rule number 8 in our drawing. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. Here we have peripheral angle ADB that rests on chord AB, and we also have another peripheral angle ACB that rests on the same chord called AB. So those two peripheral angles that rest on the same chord called AB must be equal to each other. That is to say, if this peripheral angle ADB equals to theta, then the other peripheral angle ACB must be also equal to theta. We actually can implement rule number 8 in our drawing. Why? Because in our drawing we have peripheral angle we have here peripheral angle APC, this peripheral angle APC that rests on chord AC, but we have another peripheral angle ABC that rests on the same chord called AC. So those two peripheral angles, they both rest on the same chord called AC, therefore they must be equal to each other. So if we define peripheral angle ABC as theta, then the other peripheral angle APC that rests on the same chord called AC must be also equal to theta. If you focus on the right triangle APC, in the right triangle APC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in a triangle. Likewise, we focus on the right triangle ABM. On the right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. In the next step, we proved that the right triangle ABM is similar to the right triangle APC. So why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in triangle ABM are correspondingly equal to all the three angles in triangle APC. Therefore, we actually proved that those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right angles are similar to each other, we derived that the following relationship exists between their sides. We derived that AB in triangle AMB over AP in triangle APC equals to AM in triangle AMB over AC in triangle ACP. Repeat again. We derive that AB over AP equals to AM over AC. AB is 13, AP is the diameter of the circle that is 2R, AM is 12, and AC is 15. So found out that 13 over 2R equals to 12 over 15. Here we first multiplied this equation and found out that 13 times 15 equals to 2R times 12. Here we divided this equation by 12. And we got that 2R equals to 13 times 15 over 12. Here we divided this equation by 12 and we found out that R equals to 13 times 15 over 2 times 12. Here we divided both the numerator and the denominator of this expression by 3. So in the numerator we have 13 times 15. So it is 13 times 15 over 3 is 5. So in total, after we divide the numerator by 3, we left only with 13 times 5. And we have to divide also the denominator by 3. So in the denominator we have 2 times 12. 2 times 12 over 3 is 4. So after we divide the denominator by 3, we left only with 2 times 4. 2 times 4 is 8, and 13 times 5 is 65. So actually found out that the radius of this circle R equals to 65 over 8 units. From the drawing it is very easy to see that the area of this green shape equals to the area of the circle minus the area of triangle ABC. Repeat again, the area of the green shape equals to the area of the circle minus the area of triangle ABC. The area of the circle is pi r square minus the area of triangle ABC. The area of this triangle ABC equals to the base of the triangle that is BC times the height to the base that is h over 2. Repeat again, the area of triangle ABC equals to the base BC times the height to the base that is h over 2. So the area of the green shape equals to the area of the circle that is pi r square. But R is 65 over 8, therefore R square is 65 over 8 square. So in total the area of the circle equals to pi times 65 over 8 square minus the area of triangle ABC. The area of triangle ABC is BC times h over 2. BC is 14, h is 12 over 2. So this expression in total equals to 207.394 square units. And this expression equals to 14 over 2 is 7, and 7 times 12 is 84. So the area of triangle ABC in total equals to 84 square units. And the area of the green shape equals to 207.394 minus 84. 207.394 minus 84 equals to 123.394 square units. So actually found out that in both methods, the area of this green shape equals to 123.394 square units. Okay, thank you very much.